Show the following equation has real and equal roots. So we need to compare with ax square bx plus c equal to 0. So here we'll have a will be this p minus q, the b will be 5p plus q, and the c will be minus 2p minus q. Now it's given roots. We need to find the roots, right? So we need to find the d in this case. So roots are not given, the nature is not given, we have to find it. So d equal to b square minus 4ac. So we'll go ahead and find. So the d will be b square, and the b, this is my b, so 5p plus q minus 4ac, this is my a, and this is my c, minus 2. So I need to solve this. Now d is equal to 5 square is 25, and this is my p plus q the whole square. Minus 4 into minus 2 is plus 8, minus p by q, p minus q here will be p minus q the whole square. Now if you closely examine your d, now this term, this is positive, your p plus q the whole square, so it has to be positive. So this term together is positive. Now for the next term, 8 we know is definitely positive, and p minus q the whole square is also positive because it is a square. So this term put together will also be positive. So I have two positive numbers, one positive into the other positive will also be positive. So for this I could say that my d is positive, d is greater than 0, so roots are equal. They're not equal to 0. So roots are here unequal and real. Here we could just write it again. We know d is positive, means d is greater than 0. If the roots of the following equations are equal, prove that either a equal to 0 or a cube plus b cube plus c cube equal to 3abc. We need to find the d, so we compare with general equation ax square bx plus c equals 0. So a equals, this is the a, coefficient of x square, c square minus ab, b coefficient of x minus 2 a square minus bc, and c coefficient here just a constant term, b square minus ac. So roots are equal, which means d equal to 0. So b square minus 4ac equals 0. So we have to put b square here, and our b square is minus 2. Here is b square, a square minus bc the whole square, 4ac, a is here, c square minus ab, and c is b square minus ac equal to 0. Minus 2 the whole square is 4, and this is a square minus bc the whole square, minus 4, I open the bracket, c square into b square, c square b square, c square into minus ac cube, and then we have minus ab into b square minus ab cube, minus ab into minus ac is plus a square bc equals 0. Now 4, this is a minus b the whole square. A minus b whole square is a square b square minus 2ab. So this is a square b square minus 2ab, a and b. Here we open the bracket, so this one minus 4c square b square, minus into minus plus 4ac cube, minus into minus plus 4ab cube. This is minus 4a square bc equals 0. We'll take 4 common out. What remains now is a4 plus b square c square minus 2 a square bc minus 4 if taken common out. So what will remain here is only c square b square. 4 common out, what will remain here is a c cube. 4 is taken common out, so what will remain is a b cube. 4 common out, so what remains a square bc equals 0. Now we can ignore the 4 because we have taken it common out. So a4 plus b square c square minus 2 a square bc minus c square b square. We just copy this out. We have ignored the 4 because we have taken it common out. If you notice here, I can cut two terms, plus b square c square minus b square c square. And these two terms are similar. I can put them together. So let's get on now. So we have a4 minus here minus 2 a square b square, and this becomes minus 3. So minus 3 a square bc plus a c cube. The other terms I'm just copying them out, equals 0. I'll take a common out now. From if I take a common out from the first, a cube would remain. If I take a common out from here, 3abc remains. Now I take a common out from here, c cube. I'll take a common out from here, b cube equals 0. So this is what we have. So we have two terms. So either a equal to 0 or a cube minus 3abc plus b cube plus c cube equals 0, which means a cube plus b cube plus c cube equal to, I take the 3abc on the other side, so it becomes plus 3abc. So I get my answer either a0 or a cube b cube plus c cube equal to 3abc. If the equation has equal roots, prove that c square equal to a square bracket 1 plus m square. So if they have equal roots, the discriminant d must be equal to 0. So we need to find that. So we say compare with equation equal to 0. On comparing, this is a 1 plus m square, b is 2mc coefficient of x, and the c will be equal to c square minus a square. It's given roots are equal, and if roots are equal, d discriminant equal to 0, and the discriminant in this case is b square minus 4ac equal to 0. So let's write our b square. If you see our b square, this is b, 2mc minus 4a and c. This is a, 1 plus m square c square minus a square. Now this is b square, so it will become 4m square c square minus 4. We open the bracket here, we'll get c square minus a square, m square into the bracket, m square c square minus m square a square equals 0. So 4m square c square, open the bracket again, minus minus plus 4a square, 4m square c square, this becomes minus here because minus into plus, minus into minus, plus 4m square a square equals 0. Now there are some terms which are plus 4m square c square minus 4m square c square. So what I'm left with now is minus 4c square, 4a square plus 4m square a square. Now you know you can take 4 common out. So what will remain here is minus c square plus a square plus m square a square equals 0. I can ignore my 4 because I've taken it common out. So minus c square plus a square plus m square a square equal to 0. I take the c square on the other side, so I'll get a square plus m square a square equal to c square. Now just do it up here only. In this case, I'm going to take a square common out. So a square common out will be 1 plus m square equal to c square, and I have got it. Just write it up again here. Here we had answer a square, 1 plus m square equal to c square. Here I've taken a square common out in this step.